class, I have started discussing particle physics. So basically, in particle physics, we have classified all these particles, okay, into two categories. Particles, what was two category? Elementary particles and composite particles. Elementary particles and composite particles. Composite particles and elementary particles. Okay? Elementary particles are those particles whose internal structure is not known to us. They are considered as point particles. Here, two type of fermions were there. Two type of fermions were there. One were, okay, fermions were there, and there was a third category which was made up of boson. Fermions, which were the fermions? They were leptons here. Leptons were there. Quarks were there. Second was quarks. And third were exchanged bosons. Exchanged bosons. Exchanged bosons. There, even these elementary particles, according to standard model, they were classified into four categories. First generation, second generation, third generation fermions, first generation fermions, second generation fermions, third generation fermions, and then these exchanged bosons. Okay? Exchanged bosons. Here, this first generation, it is going to have electron family, electron and electron neutrino. And two quarks were there, up and down. These two quarks were there. They were very stable particles and lighter one. As compared to first one, second generation is a little bit heavier, as well as they are less stable. So here you are having muons, mu minus and nu mu, and two quarks were there. They are charm and strange. Charm and strange was there. In third generation, we are having tau particle and tau neutrino, and two quarks were there, top and bottom. So these are first, second, and third generation of fermions. This third generation of fermions, they are very heavy as compared to the first two generations, and you will find out you can say they are unstable. They are less stable as compared to the first one. And in these exchange bosons, you are having photons. Photons you are having gamma. You have gluons, Z naught, W plus minus, and then there is graviton. Gravitons. Photons, they are the exchange particle for EM interaction. Gluons, they are the exchange particles for strong interaction. They are heavy bosons. They are the exchange particle for weak interaction. And last one, this is for gravitational interaction. So first we have discussed these aspects. And here, if you look at these composite particles are those particles whose internal structure is known to us. Whose internal structure is known to us. Basically, their quark structure will be known, and they are called as hadrons. Hadrons, in general, they consist of two type of particles. One is mesons. Mesons. These mesons, they are having an internal structure, one quark. They are made up of, every meson is made up of one quark plus one antiquark. One antiquark. While these here, they are baryons. Second category here, they are baryons. And if you look at baryons, they are made up of 3 quarks. They are made up of 3 quarks. Baryons, they can be classified into 2 categories. One is nucleons. Nucleons. Nucleons, it consists of proton and neutron because they are called nucleons because they are found out inside the nuclei. And second category is hyperons. Hyperons. So this is the classification of these particles I have discussed in the last class. So in the last class, I have discussed this aspect, how to classify, how to start classifying these particles. Okay. Next, after this, I have started discussing different categories. I started with photons. Okay. First, I started with this photon, and then I go for leptons. So I was at the discussion of leptons. So first category that I have discussed, that was photons. So photons I am not writing, but what is important about this category of photon, whenever a photon is appearing in in an interaction, interaction equation will be known to you, and if photon is appearing in the interaction equation, then it will be like this. It may be any interaction, then that will be electromagnetic interaction. That will be electromagnetic interaction. So this is one of the most important aspect. Second, you have to remember what is J pi. J is the spin here, pi is the parity. I'm talking about intrinsic spin, intrinsic parity of the photon. That is 1 minus. 1 minus. So for photon, I have discussed various features which you have to remember. Out of those, these 2 important features are here. Then I start discussing second category, leptons. Leptons can interact in 2 ways. One way will be weak interaction. Weak interaction they can participate, and if they are charged particle they can also participate in electromagnetic interaction. Okay? In electromagnetic interaction. So in 2 type of interaction they can participate. They can participate in these 2 type of interaction. One is weak interaction. Another is if they are charged particle, interacting particles are charged particle, then that can be electromagnetic interaction. Here, what is important, if leptons are appearing, okay, then that cannot be strong interaction. So I can say leptons do not participate, do not participate in strong interaction. Strong interaction. Another important aspect is because this is a category of particles, lepton, which is behaving in a distinguished way as compared to other particle. So you have given a number to them that is called as lepton number. So for all the leptons, lepton number is 1. So this is for all the members of leptons means electron here. For electron neutrino, it may be ton, ton neutrino, ton neutrino, or this will be, sorry, this will be mu should be first mu, and this will be nu mu. So this L is 1 for all of them, but they are representing 3 different families here. 3 different families. So for this family, a new number is given, that is electron lepton number, that will be +1. For this family, alto number will be +1. And for this family, L mu, this number will be +1. If you look at other numbers for these leptons, strangeness number was 0 for all of them. Because they are leptons, not bosons, so baryon number is 0. They don't participate in strong interaction, so I number, isospin number is 0. as well as I3, that is also 0. So this is about leptons. So leptons is made up of three families. One is called as electron family. S- Second one is called as actually muon family. I have written this lower, but this is second family, and this is third family. Okay? So please write it by flipping it. Okay? So I was here. I have discussed up to this point. Now, in the last class, I have discussed leptons, but apart from these leptons, there are anti-leptons also. So corresponding to leptons, there will be anti-leptons. Their anti-particles will be there. Okay? Apart from these particles, there are anti-particles also. Anti-particles also. One thing you have before I discuss anti-particle, one thing is important. Please write it as a note and circulate. Uh, fermions, fermions, not only for leptons, for all the fermions. This is applicable for all the fermions and their antiparticles and their antiparticles, their antiparticles have have opposite have opposite parities. Remember this always, opposite parity. So fermions and their antiparticles always have opposite parities. So their parities will be opposite. Remember this aspect. If you want to write by side, you can write bosons and their antiparticles. If you want to write, you can write here bosons and their antiparticles. And their antiparticles particles have same parity. Have same parities. Have same parities. This is. So now here I'm writing first I'm writing particle. Particle means leptons. Okay? And then antiparticle. Antiparticle. So first family was electron family. Okay? This will be nu E. What will be their antiparticle? That will be E plus. What you call it as? You call it as positron. Positron. Okay? Second is nu E. Its antiparticle is nu bar. Antineutrino. This is called as antineutrino. This is first family. Okay? Here, what will be their spin and parity? Their spin parity will be 1 by 2. Spin will remain half. Spin can never be negative. Try to understand spin is never negative. When you write plus minus 1, you are writing its orientation. Plus and minus 1, that is not saying that spin is minus 1. Actually, that plus minus 1 is representing their orientation with respect to applied field. Whatever internal or external field is there, with respect to that field, they can have two orientation. Electrons can have up spin or down spin. Up spin orientation means Z component of the spin is parallel to the applied field. So basically, spin they can have two possible orientations with respect to applied field. Applied field. One is called as up orientation, up spin you call. Another will be down orientation or anti-parallel spin you call it. Up orientation or parallel orientation means Z component of the spin is parallel to the field. But spin is half. Remember this, if I break the homogeneity of the space and I place a spin here in this suppose here I place a magnetic field or any field. This is in general we consider the direction in which we are breaking this homogeneity or and isotropy, basically that is considered as z direction. If you place a spin here, what will happen? This spin, electron spin, it can have two possible orientation. One orientation will be like this, and another orientation will be like this. So these two possible orientation are there. But remember this, basically here how to represent spin state, that will be S, and you write it as ms. S and ms. This is the way to represent. Then this spin is half beta. Spin will remain half, but its orientation that is represented by ms, that is up orientation. So what you have, its z component here, this is L vector. L vector. So its z component will be this. Okay, this will be, so this will be L cos theta. This is suppose theta 1. So L cos theta 1 means this component. Here this will be plus 1 by 2 h cross. So this is Lz component. If you write it, this is Lz component of this. So Z component is parallel to the magnetic field. This Z component, that's why this is called as up spin state or parallel orientation. But parallel orientation doesn't mean कि spin is plus half or minus half. Spin is still half. Only its Z component, it is equal to 1 by 2 h cross. So this is representing parallel orientation. Z component is parallel to the applied field direction. So this will be 1 by 2 plus half. So this is up orientation of the spin. But if you look at this here, spin is still half. Spin is not going to be minus half, but its Z component, if you write its Z component, this will be the Z component this time. This will be the Lz. So this Z component is anti-parallel to the applied field. And what will be its length? That comes out to be minus 1 by 2 h cross. So this will be minus half. So basically this plus and minus, this plus half and minus half, this plus half and minus half, they are representing this plus half and minus half. They are just representing orientation. Spin doesn't change. So that's a misnomer that spin will be plus half and minus half. So never confuse with this. Spin will remain plus half. So what will be the spin here? Spin will remain half. But parity, they are antiparticles of the fermions. So what was the parity for leptons? That was plus. So this time it is going to be minus. This time it is going to be minus. So ये कितना होगा बेटा? That will be minus. Number 2, second family, this will be muon family, mu minus, and this will be nu mu. This will be nu mu beta here. Nu mu. Here, their antiparticle, it will be mu plus, and this is nu mu bar. And third family, this is tau family, tau minus, and this will be tau plus, and this will be nu tau. This will be anti-neutrino. This will be like this. Please note it down. I will remove it. This was just to explain you what will be j pi. That will be 1 by 2 minus 1 by 2 minus 1 by 2 minus 1 by 2 minus. This will be. So now, please. So here, it is like this. Now, next is, what was the next property of the leptons? That is lepton number. What is the next property of the lepton? That is going to be lepton number. So lepton number was how much? For the leptons, that was plus 1. So for antiparticles, lepton number will be opposite. That will be minus 1. So how much it will be? This will be minus 1, minus 1, minus 1, minus 1, minus 1, minus 1. Lepton number is going to be minus 1 beta. Here, what will be the lepton number? Lepton number will be minus 1. Is it clear? Why lepton number is? Because -1 is representing that they are anti-leptons. -1 is representing they are anti-leptons. If you look at this Le for electron family, here now I'm defining for antiparticles. What I'm defining these numbers, they are for antiparticles. They are for anti-leptons. Remember this. For this will be -1, this will be -1. For other, it will be 0. If you look at L mu, this will be 0, 0. This will be -1, -1. This will be 0, this will be 0. If you write L tau, this will be 0, 0. This will be 0, 0. This will be -1. This will be -1. This will be -1. ठीक है? Now, next is baryon number, strangeness number. This is I3. All these numbers together, they will be 0. So these are the numbers which are associated with these anti-leptons. So I have discussed each and every leptons as well as for anti-leptons. So I have written here numbers which will be required for leptons as well as anti-leptons. Remember this, these leptons, most of the time they are participating in weak interaction, but if they are charged particle, they can also undergo, okay, through they can also interact through electromagnetic interaction. They can also interact with electromagnetic interaction also. This was second category. Third is mesons. Third category is mesons. Mesons. What is most important aspect of meson? Meson का सबसे important aspect क्या है? That they are strongly interacting particle. First is they participate, they interact only through strong interaction. Strongly interacting particles. They are strongly interacting particles. They are strongly interacting particles. Their spin and parity, if you look at their spin and parity, that is 0 minus. So what type of particles are they? They are bosons. They are bosons. Next, they are having an internal structure made of, they are made of one quark plus one antiquark plus one antiquark. They are made of one quark and one antiquark. So most important aspect of mesons are that they are strongly interacting. They are in when you are solving question, this aspect will help you, as well as you have to remember their parity as well as their spin. Spin is 0. So for mesons, their spin is 0. Okay? Now, here I am writing mesons. There are three categories of mesons. One is pi meson. First is pi mesons. Pi mesons. In pi mesons, you are having कौन सा होगा बेटा बताओ? First, that will be pi plus. Second, two type of particles are there. Two particles are there. Pi plus and pi naught. That will be pi plus and pi naught beta. This will be. Second category is here. Second category is K mesons. K mesons. That will be K plus and K neutral. K naught or K neutral. This is pi neutral. This is also called as pi neutral. And last is eta meson. Eta meson. Eta meson. Eta neutral. So three categories of mesons are there. Later on, After one class, I'm going to discuss one more category of meson. They are called as D mesons. They are called as D meson. D mesons are those mesons whose internal structure consists of a quark that is called a charm quark. Okay? The internal structure consists of a charm quark. That type of meson heavy, they are relatively heavy with respect to these. They are D mesons. Later on, I am going to discuss with it. Now, what will be the J pi here? Spin and parity. That is 0 minus, 0 minus, 0 minus, 0 minus, 0 minus. That is their spin and parity. 0 minus is the spin and parity. If you look at their lepton number, they are not leptons. They are not leptons. So lepton number is 0 for them. They are not baryons. Lepton means all the leptons. Here, leptons will consist of, I'm writing here, L, Le, L mu, L tau. I'm talking about all the three. Next is baryon number. Next is baryon number. They are not baryons. They are mesons. They are a different category. So that will be 0. But a important number, strangeness number, is possessed by these K mesons. So here, one of the important number is strangeness number. Right here S is called as strangeness number. You can write here strangeness number. This S is called as strangeness number. They are exhibiting some very different properties as compared to other. So this strangeness number is 0 for this. But these K mesons, remember this. These K mesons, they are going to have +1 and +1. So K mesons, they are having a strangeness number +1, +1. That's why I have encircled it. I have encircled it. This will be 0. Other than this, they are having I number. ठीक है, I number. Actually, I number is representing a multiplet. Some of the particles are like this. For example, here there are three. These two particle, one antiparticle. I'm coming back to this. Please just wait. Actually, these three particles, try to understand why this I number was introduced. This is pi plus, pi naught, pi minus. Here this pi minus, that is antiparticle. Pi minus is antiparticle, they are particles. So, if you look at these particles, what do you find out? They are going to represent a single particle state. This is called as pi state. This is called as pi state under strong interaction. If you are looking at these particles through the view of strong interaction, if you are observing these three particles in strong interaction, then you will find out that strong interaction is unable to separate them out. Strong interaction consider all the three particles as single particle, or rather than particle, strong interaction consider these three particles as the single particle state. Actually, strong interaction cannot recognize charges. It is blind to charge. It is blind to charge. It cannot observe charges. So for strong interaction, all the three particles are same. So they are representing single particle state. ठीक है, interaction. But what happen if you place these three particles in electromagnetic interaction? Then this single particle state, it is going to split into three particle states. It splits, it gives rise to three particle states, pi plus, pi naught, and pi minus. So basically this particle state is single in case of a strong interaction, while it splits into three different particle states. Because charges are different and electromagnetic interaction, it can recognize charges. Electromagnetic interaction, it can recognize charges. So a single particle state is splitting into three charged particle states. Now, how many states are created? Three states. So it is a multiplet whose multiplicity is 3. Okay? And very similar to atomic physics, how we define this multiplicity? This is 2i plus 1. So 1 will cancel out, it will be 2 by 2, that will be 1. So I number for these three states, isospin, that will be 1. So corresponding to this type of splitting, a multiplets are coming into the picture, and these multiplets, they are defined in terms of isospin. So isospin is used to represent
I
these
equal to 1.
I equal to
Sir,
1, 1. It will be 1. I have written I is 1, correct, beta. So basically here isospin is used to represent these multiplets which are appearing in electromagnetic interaction. In strong interaction, they are representing a single particle state, but as they enter, ठीक है ना, they are approached by electromagnetic interaction. They are giving rise to a multiplet. So whatever multiplicity is there, corresponding to that multiplicity, we are going to define isospin. So here isospin is 1. Next, if I is 1, then what will be I3 or IZ? You can write it as I3 or IZ. Both are used. So for I, it will start from +1, 0, and -1. There will be three possibilities for 1. That will be +1, 0, and -1. Now question is, actually these three states, they will be represented by three different I3 numbers. So to denote them separately, to represent them separately, you have to give a new number. That is I3 or IZ. Highest charge carrying particle will carry highest value of I3. What is the highest value of I3? That is +1. So highest value of I3 will be possessed by the particle which is having highest charge. So this is a convention. Now, next charge after plus, it will have this charge is less than plus 0 it is. So it will be 0 here, and then lesser charge further. So that will be -1. So it will be +1, 0, and -1. Okay, it will be like this. If you consider these k particles, they are also going to possess this. If you consider these k particles like k plus, this is k state in strong interaction. But this single particle state, it will split into two states. One will be k plus and another will be k naught or k neutral. So this time multiplicity, a single state is splitting into two, so multiplicity is 2, and this will be 2i plus 1. So what will be I beta? I will be this time I 1 by 2. So I is going to 1 by 2. So what will be the I for this? I will be equal to 1 by 2. So isospin for this case will be 1 by 2. Now for I, what will be I3 or IZ? That will be plus half to minus half. So highest charge is going to carry highest value of I3. Then this will K naught, so this will be minus 1 by 2. So they are going to possess these isospins. They are going to possess these isospin numbers. So isospin numbers were introduced because some single particle states, they split into multiplets in the presence of electromagnetic interaction which can recognize charges. So due to their charge recognition capability, a single particle state, it is splitted into multiplet. So to represent these multiplets, it's a multiplet of 2 or 3 on that bay or 4. On the basis of this multiplet number is there, and correspondingly we defined isospin. Correspondingly we define isospin. And corresponding to number of states, now we need to give some different distinction to them, different names to them. It's like this. So we are giving numbers. That is I3. Because they are multiplet, so automatically there will be some numbers that is called as I3, third component of the isospin or Z component of the isospin. In this way, this isospin is coming into the picture. I will, whatever I have discussed with you, I will dictate you in isospin number. I will later on, I will discuss. So here, what is the isospin for this? That is 1. It behaves very similar to spin. That is 1. ठीक है, this is half for this, half for this, and this is 0. This is. These are numbers you have to remember. They are isospin. If you write third component of the isospin, that will be, sorry, for I plus, it will be plus 1. For this, it will be 0. Okay? Pi minus, that is an antiparticle here. So that will go to antiparticle category. Then it will be plus half for this, minus half for this, and it will be 0. So these are the numbers which you have to remember. Okay? Regarding these mesons, you have to remember these numbers. They are particles, mesons. They are mesons, beta. And now corresponding to these mesons, there are antiparticles. Anti-mesons are there. Now come to the anti-mesons. Please note down this. Then I will go to the next category. Okay? Anti-mesons. Anti-mesons, beta. Next is, I can write anti-mesons. So first was pi plus. So corresponding antiparticle is pi minus. For pi naught, remember this, antiparticle of pi naught is pi naught. Later on, I will explain on the basis of quarks. So antiparticle of pi, you can write a note, antiparticle of pi naught, pi neutral, pi naught is pi naught itself. Second, this you can observe on the basis of quark structure. Sorry. Second is k plus was the particle, so antiparticle will be k minus. This is k naught, so its antiparticle is different. This is k naught bar. And third is eta naught, its antiparticle is different. That will be eta naught bar. So they are anti-mesons. What will be J pi? Remember this, they are bosons. Spin remains same, parity remains same. So for bosons and their antiparticles, for bosons and their antiparticles, their parities will remain same. So this will be 0 minus, 0 minus, 0 minus. This will be 0 minus. Next is lepton numbers, Le number, L mu number, L tau number, as well as I'm writing B number here. All these numbers are 0. They are not leptons and baryons. So these numbers are 0. These numbers are 0 because they are not leptons. They are not belonging to that category. Next is strangeness number. Only these kaons, they are possessing strangeness number, these particles. So their antiparticle, they are going to possess opposite to that. K plus and K naught, they were possessing strangeness number plus 1. Now, this K minus and K naught bar, they are going to possess minus 1 strangeness number. Okay? Others, they don't have. They are not strange particles. If you look at I, it will remain 1. It will remain 1. It will remain half. Isospin will be 1. This will be half. It will be 0. But if you look at I3 number, for this, this is pi minus, so that will be minus 1. Pi naught, it will be 0. Here, who is having higher charge, minus or 0? 0 is higher as compared to minus. So K naught, this is going to have plus half. And that is minus half. You can also consider that K plus is having plus half, so K minus will have minus half. And this will be 0. So they are anti-mesons. I have written every number that will be required to you for solving questions. So every detail I am giving you at the same position. So these are anti-mesons. Next is baryons. Next is baryons, beta. Next is baryons. Baryons. Baryons, they can be classified into two categories. So first is nucleons. First category of baryons is nucleons. Nucleons first, they are find out, they are nucleons, they are called nucleons as they exist inside they as they are find out, they are find out inside the nuclei. They can exist outside the nuclei also, but originally, okay, in general, they are observed inside the nuclei. They are forming the nuclei. That's why they are called as nucleons, or find out inside the nuclei or in the nuclei. Nuclei. Second, okay, they are fermions. They are fermions. Why they are fermions? Because if you look at J pi, that is 1 by 2 plus 1 by 2 plus. Whenever they interact, I'm saying whenever they interact, means third, they interact, they interact with other particles, with other particles through strong interaction, through strong interaction, through strong interaction. However, however, they can decay, they can decay via weak interaction, weak interaction. ठीक है, interaction. ठीक है, if you look at A means a neutron, it can decay into proton. Neutron, it may decay into proton by emitting a beta minus particle plus antineutrino. Antineutron. Neutron can decay into proton for the emission of beta minus particle. Beta minus is electron and antineutrino. This interaction, this decay, this is decay. Try to understand here, neutron is not interacting with anything. This is decay of neutron. This decay can take place. This decay can take place inside inside as well as inside as well as outside the nuclei. Outside the nuclei. Outside the nuclei. So this decay can take place inside as well as outside the nuclei. Option here B, you can write this proton can decay into neutron plus this will be beta particle plus neutrino. ठीक है, but this decay can take place only inside the nuclei. Outside the nuclei, this interaction is not possible because mass of proton is less than neutron. ठीक है, so you can write here, please write, this decay can take place only inside the nuclei. This decay can take place only inside the nuclei. This decay can take place only inside the nuclei. Full stop. Full stop. Outside the nuclei, this decay is not possible. Outside the nuclei, this decay is not possible because mass of proton, is less as compared to neutron. Because mass of proton is less as compared to mass of neutron. So 2 टाइप ऑफ न्यूक्लियंस आर देयर. ठीक है, कितना टाइप का न्यूक्लियंस है? 2 टाइप ऑफ न्यूक्लियंस आर देयर. One is called as proton, another is called as neutron. So 2 type of are there. So you can write here nucleons. Nucleons. One is called as proton. This is neutron. If you look at this j pi is 1 by 2 plus 1 by 2 plus here. ठीक है. Here one more thing is it is a lifetime. Lifetime. Tau, actually this is mean lifetime. Tau. This is very stable particle. This is very stable particle. This is unstable. Unstable particle. ठीक है, one is very stable, another that is important. That's why most of the heavy particles finally they convert into proton. जो इसका ये this will be 930 930 roughly 933 second is its mean lifetime. ठीक है, within this time this will decay. It will decay within this time. Within this time this is going to decay बेटा. इतने टाइम में ये decay हो जाता है. और अगर मैं प्रोटॉन्स के लिए है सो आई थिंक 1032 years. दिस जस्ट फॉर यू. इसे एक बार चेक कर लेना प्लीज. चेक दिस नंबर 1032 years. This will be, this is a lifetime. Next, they are not leptons, so automatically lepton, Le, L mu, L tau, they are 0, but they are baryons. So this time that baryon, this is B is +1 for them because they are baryons. They belong to the family of baryons. That's why this is +1. If you look at their strangeness, they don't show strange behavior, so that is 0. They are having iso spin. If you look at strong interaction, this nucleon, proton, neutron, they are same. They are representing single state in strong interaction. But as you place them in electromagnetic interaction, they will split into 2. This will be proton, this will be for neutron. So in EM interaction, a single particle state is split into 2. So here I number or multiplicity, you can say that will be 2. That will be 2I plus 1. So this is 1, so I will be 1 by 2 here. So what will be IZ? ठीक है, IZ for this, that will be plus half. Why? Because proton is carrying higher charge, neutron is neutral. For this IZ, that is minus half. So here you can write this is half, this is also half, and I3 number, that is plus half, and this will be minus half. So these are the numbers which you will require for this here. Here you should remember this is a very stable particle. So, and other particles which are heavy as compared to proton, they are some or how their lifetimes may be different, but they are unstable, relatively unstable as compared to this proton. You can look its half is the mean lifetime. So other particles, they are unstable. So they are going to decay. ठीक है, after some time automatically whatever time may be, they are going to decay. When they will decay, finally that decay will stop where? That decay will be continuous and they will finally convert into these nucleons. ठीक है, they will convert into nucleons finally. So they are nucleons. Only two type of nucleons are there. If you write anti-nucleons, anti-particles, anti-nucleons, I'm writing here anti-nucleons, so they will be p bar, that will be n bar. If you look at, spin will remain half because they are fermi fermions, their parity will be changed. Fermions and their antiparticles, they have opposite parities. So this time it will be minus, it will be minus. Okay, I'm leaving this column, I don't have this number. Okay, and this will be 0. This will be 0 here. Baryon number, that will be -1 and I'm writing -1 for them. Strangeness number is 0, 0. If you look at I number, that will be half and half. And finally, this will be -half and that will be +half. It is. So these yellow lines, they are representing the numbers for anti-nucleons. For anti-nucleons.
Lifetime is same. Is lifetime
Lifetime
same, sir?
चेक करना पड़ेगा मुझे. I don't remember that lifetime. ठीक है. You can look at the Google or something, or I will give you tomorrow. I don't have lifetime right now. Actually, I don't, in general, I don't like to remember lifetimes. There is no need of lifetime, first thing I'm going to tell you. But here it will be needed, particularly for this proton. Why I'm telling this? Only for proton and neutron. That will be required in different questions. Many times logically, when we are going to explain something, we will require this fact. So only for these two you can remember this aspect. For other, I will not suggest you to remember. There are a lot of lifetimes. We cannot, how can we remember all these numbers? थोड़ा सा number याद रखना मुश्किल है. We cannot remember this. And I will not suggest anyone. So this is nucleons. This is first category of baryons. This is the first category of baryons. Second category is hyprons. बेटा. Second category is hyprons. तो सेकंड कैटेगरी क्या है? हाइप्रॉन्स. अभी टाइम है? यस. नेक्स्ट इज हाइप्रॉन्स. फर्स्ट हाइप्रॉन्स. ठीक है. व्हाट आर द प्रॉपर्टीज ऑफ हाइप्रॉन्स? फर्स्ट थिंग, दे आर फर्मियंस. तो फर्मियंस तो हैं ही. दे आर फर्मियंस. दे आर फर्मियंस. ठीक है. स्पिन इज हाफ. Parity is positive, but one of the hypron is there whose spin is 3 by 2. That's why I'm not writing here J and pi. That I will write for individual. They are second. They are unstable particle. They are unstable. You can write here. They are unstable particle. Please write. They are unstable particles. They are unstable particles. One can consider these particles. One can consider, full stop, one can consider these particles as the composite state. One can consider these particles as the compound, not composite not a correct word, compound state. One can consider it as a compound state, not composite, please correct it. One can consider these as compound state of mesons and nucleons. Which finally decay via this compound state, which finally decay via weak interaction, weak interaction, which finally decay via weak interaction, producing nucleons, producing nucleons. This is the second property. They are unstable particles. ठीक है ना? They are unstable particles. लिखो, they are produced they are produced by they are produced they are produced by strong interaction. ठीक है, these are important aspects. They are produced by strong interaction. Interaction. They are produced by strong interaction. They also interact. They, I'm not talking about decay. They will decay by weak interaction. Decay means if you are having a decay means like this, if you are having sigma plus, it is it is giving rise to me x plus y plus z. This is called as decay. This is called as decay. You can write as a note कहीं पे छोटा सा. When a single particle is converting into other, it's not interaction, it is decay. This is called as decay. Interaction is like this: if the sigma plus is interacting with some particle like this, this is called as interaction. So when this decay is taking place, that decay will be via weak interaction. That will be via, but they they also interact through ये वाला जो interaction है, they also interact through strong interaction. They also interact through strong interaction. Strong interaction के through बेटा interact करते हैं. So these are the properties of these hyperons. So today I am going to stop here. ठीक है. Further I will start discussing this. I will discuss hyperons. ठीक है ना. And then we will move to strangeness number. I will explain you strangeness number, isospin number, I3 number, and then quarks will be there, and we will write quark structure of these. ठीक है ना, all these. So in the next class, I will try to cover up to quark structure.